Hi everyone, this is our final project about statistical analysis on various factors of expected life expectancy. My name is Tianyi Nie, and my partner is Zhuo Zhou.
Hello.
We will introduce our project from 4 parts as shown: background, data pre-processing and feature selecting, modeling and analysis, and conclusion and future direction. The first part is background. Although there have been lots of studies undertaken in the past on factors affecting life expectancy considering demographic variables, income composition, and mortality rates, it was found that effect of immunization and human development index was not taken into account in the past. In a nutshell, we will focus on immunization factors, mortality factors, economic factors, social factors, and other health-related factors as well. The next part is about data pre-processing and feature selecting. Firstly, we made several box plots and histograms to check for the obvious outliers. Concluding from the plots, the outliers exist in adult mortality, infant deaths, BMI, population, and GDP. After adopted conditions below, we exclude the outliers by replacing with nulls. Next, we go through the whole data set and examine the missing values. We found that the percentage of null values is less than 30%, and we decided to impute the missing values with the mean of all other values of the feature. Then we generated the correlation heat map and tried to identify the potential collinearity among features. It is shown that there is high correlation between under 5 deaths and infant deaths, GDP and percentage expenditure, sinus 1 to 19 years and sinus 5 to 9 years, income composition and of resources and schooling. Also, we calculate the relationship for each features with target variable, life expectancy, stored coefficients, p-value, level of relationship, and significance into the table below. From the table, we can conclude that population is the insignificant feature since its p-value is greater than 0.5. Also, for the 2 pairs of collinear features, we decided to drop the ones which have weaker correlations with target variable. Therefore, we decided to drop population, percentage expenditure, and infant deaths to form a sparse model. Now I'll pass it to Joe to talk about modeling.
So for modeling, we firstly fit a linear regression based on the feature we selected during preprocessing. We got the training MSE to be 17.23 and test MSE to be 32.54, which is much larger, meaning that the model is overfit. So this is probably because our model contains too much features. Then we use lasso to penalize on the complicated model. We create a grid for lambda to search for the best value using 3-fold cross-validation. And we got the best lambda, which equals to 0.1. And the test MSE is 20. One advantage of lasso is that it can force some coefficient to be 0. So we can get a sparse model, which is better for us to interpret it. Here's the coefficient from lasso model. We can see that the measles and under 5 deaths and thinness between 5 to 9 years have 0 coefficient. And status and schooling have a significant positive influence on the life expectancy, which is reasonable since a more developed country will result in a longer life expectancy. And people with higher education level would have better living quality. And HIV has a negative influence on life expectancy, meaning that a higher death rate of HIV result in a shorter life expectancy. We also fit a random forest regressor by starting with a baseline model with number of estimator equals to 500 and random state equals to 42. Then, and we got the baseline accuracy, baseline test MSE about 3.177. Then we create the following grid to randomly choose different combinations and use threefold cross-validation to evaluate. And then we got our best parameters based on the search, and our final test MSE is 2.976, which improved about by about 6%. And we also generate a plot for feature importance to better for us to interpret the model. Here's the plot for feature importance. We can see that the adult mortality, HIV, death rate, income composition of resources, and schooling are the most important factors. And here's our conclusion. And based on the two questions we propose on our proposal, we can answer them right now based on our model result. And first, the significant features are that actually affecting the life expectancy are status, adult mortality rate, HIV death rate, income composition of resources, which is the same as a human development index, and also the education level. And the second question is that what actions should a government take to improve the expected life expectancy? From the model, we can say that the government should focus on improving the health system, education level, and advocate people the importance of body weight control. And for the future direction to improve the work, since different countries might have different situations, so they should not fit the same model. Instead, we can use unsupervised learning technique to cluster the same countries before modeling and use the different models on different clusters. Thanks for watching.